Welcome back. Today we are going over basic collision problems. So the main idea with basic collision problems is momentum is equal to mass times velocity. Um, we use momentum because in collision we have two objects moving towards each other and colliding, and the biggest thing to note is momentum. We write momentum with the letter P, and again that is just equal to mass times velocity. In a collision, if there are no big outside forces, the total momentum is conserved. So what that means and how we can write that is you can think about it as the momentum before collision is equal to momentum after. Right. If the momentum total before is equal to the momentum total after, that means no momentum was lost or created. Conservation of momentum. Now, to put this in formula form, to make it a little more useful for us to solve with, we can write as m1 or m of object 1 times v1 initial plus m2 v2 initial is equal to, so as you can see, this is the total momentum before. So this is all equal to m1 v5, sorry, v1 final plus m2 v2 final. And similarly, this is just the momentum after collision. So a big thing to also remember is choosing positive and negative directions. I like to draw my coordinate system like this, where y is up and positive x is to the right. So this would mean up and down. Up is positive y, right is positive x, down is negative y, left is negative x. But usually you can create your own coordinate system, but this is just the most common way. Now, let's go ahead and get into our first problem. We have a 10-kilogram object is sitting still. It explodes into two pieces. One piece has a mass of 4 kilogram and moves to the right at 12 meters per second. The other piece has a mass of 6 kilograms. Find the velocity of the 6 kilogram piece. So, this one's a little more difficult than the common problem, but we can still work it out. So, before the explosion, the object is at rest. So we have P before, so momentum before is equal to 0. After the explosion, the momentum is just V1 or M1 V1 final plus M2 V2 final. So if we use conservation of momentum where we do the before is equal to after, we'll get 0 is equal to m1 v1 final plus m2 v2 final. So now if we plug in everything we have, so we have, this would be 0 is equal to 4 times 12 plus 6 times v2 final. Rearranging for v2 final, we get v2 final is equal to negative 8 meters per second. So what this negative 8 meters per second tells us is that the velocity of the 6 kilogram piece moves to the left at a velocity of a magnitude of 8 meters per second. So negative means to the left. And to be extra careful on your exams, make sure you draw your coordinate system to show positive x and positive y directions. All right, hopefully that made sense. Now let's move on to the next problem. We have a 3 kilogram cart moving to the right at 5 meters per second hits a 2 kilogram cart moving left at 4 meters per second. After the collision, the 3 kilogram cart moves left and at 1 meters per second. Find the final velocity of the 2 kilogram part. So I'm going to draw my coordinate system like this. So to the right is positive. So I'm going to write out the equation. So m1 v1 initial plus m2 v2 initial is equal to m1 v2 final plus m2 v2 final, and this should be v1. Now if I plug everything in, we'll get 3 times 5 plus 2 times negative 4 is equal to 3 times negative 1 plus 2v2 final, because the 2 kilogram cart is my object 2. Now rearranging and solving for v2 final, we get that this is 5 meters per second. And notice how the answer is positive. So what that means is that the 2 kilogram cart moves to the right at a magnitude of 5 meters per second. And there you go. That is basic collision problems with conservation of momentum. In my next video, I will go over elastic collisions versus inelastic collisions. So make sure you check that out. And I'll see you next time.